Morning, Professor.
Hey, good morning. Who is this? Keenan. Keenan.
Yeah.
Hi. Yeah, let me switch to proper
I'm gonna run
gallery.
to the bathroom. I'll be right back.
Hey, Keenan, you weren't here last class, right?
Yeah, I missed last class.
But did you get a chance to catch up?
Yeah.
Great. In fact, Van was coding last class, and I think he just emailed me saying he's not able to make it to class today, but he posted the link to the coding rooms project. If one of you can pick it up, you know, um, at some point. How are you feeling, Ashwat?
I'm doing well, Professor. How are you?
Good, thanks. You're all caught up, I hope.
I'm in the process. I got some stuff done this weekend, and I'm still trying to catch up. So hopefully it'll be done get all the quests done before the final.
Okay, great. Are you any of you guys planning to do my 2B or 2B at all at Foothill?
Not
No?
at Foothill. No.
Yeah. Keenan, are you? You must have stepped out or something. Yeah, but regardless, I think you should, wherever you do it, whether at UCSB or even on your own, it is worth going all the way to the end of the trail, master all of the algorithms. And I think it'll be very useful. All right. Well, we could wait for the other folks to turn up, or we can. Well, I don't know. I don't think we should start, discussing class material yet, or start coding. So, how about we just wait for a little while, okay, until about 8:10 or 8:15, until more people turn up. In the meanwhile, if you want to ask me something, or if you have questions, feel free to ask. Except save the questions that are more general purpose, right? So may help many more students. Wait until other people show up. But if you have, something more specific to you, or if you say, if you have a question, hey, I missed the midterm or something like that, those kinds of things pertaining to you and some very few other people, that's fine. You can ask them now. Otherwise, what I'll do is I'll just turn the laptop around for about 5 or 10 minutes. Yeah. And you and Keenan can talk. Try and keep the airwaves occupied at the very least, so that people just don't, Kai's here now, but more people talk, the better. Yeah, okay. So we'll start at 8:10 or something, unless you call me and ask me a question. I'll be back here and I'll start talking again. But otherwise, just feel free to talk, okay? Yeah.
Progress.
How's it going, Sean?
Good.
All right. Well, okay. Well, we have a few people here. We can start talking about technical stuff already. And I think, well, we wait. I mean, we don't have to start coding until 8:15 or 8:20 or so, but can start talking about technical stuff or what we're going to do today. Anyway, the plan for today. Do you guys have any questions about where we're at right now? What our plan is going forward? Essentially, this week and next week, I'm hoping to cover linked data structures, basically linked list, right? And things you can do with a linked list. So that's what I'm planning to do. And that is really the end of season 1 of C++. Hey, guys, am I just talking to myself? Because the way I see it, I'm the only person on screen and I'm talking to myself. Great, thank you all so much. Yeah, so what was I saying? Yeah, this is the end of season 1. You know, if you look at this class as a series of episodes, right? cs2a is the end of season 1, where you get to know the first boss, pointers. Yeah, and then the next episode will take pointers. Now that the pointers become your mini bosses in cs2b, right? And then you're working towards a grander boss there, okay, in cs2b. But at the end of cs2b, you will actually conquer that also. And cs2c is where you start marching towards the real fruits of programming, and not even C++, right? I think, you know, when you get to cs2c, my personal opinion is that there's only one cs2c, okay? It has many names, cs3c, cs1c, and so on, but everything at the C level, they're all the same, because you're not thinking in terms of the language anymore. That's what I told my cs2b students yesterday, and I thought that was actually a very interesting thing to myself, because when you get to cs2c or 1c or 3c, the language basically fades into the background. So the meaning, what I mean is that by the end of 2b, you're so conversant with C++ that you stop thinking in C++ explicitly, right? You just start thinking figuratively. And then when it comes time to express your thoughts, you will choose the language most suited to express your thoughts, right? Well, you know, even when you're talking, right? Many of us who are multilingual, for example, right? We speak in more than one language. When we're talking to other people, we automatically switch between code switch, right? It's called code switching. We speak in one language, and then it's easier to speak that in this language, and so we switch, and then back and forth. It just happens naturally. Yeah. So that when that happens, it means that you're equally comfortable in both languages. And so you're not thinking in any particular language anymore, but you're thinking in an abstract way. But when it flows through your, physical apparatus, from your mental machinery to your physical apparatus, and your mouth has to enunciate it and things like that, based on your environment and everything, you just pick the most optimal technique to convey it. And sometimes it is English, sometimes it may be Chinese, sometimes it may be an Indian language, and maybe sometimes it is going to be C++ or Python or JavaScript. It doesn't matter. So as the situation demands, you choose the right conduit to express your thoughts. And then C++ becomes one of those conduits. And when you reach CS2C or 1C or 3C, Python and Java and C++ should not be in the forefront of your consciousness anymore, right? So, and I think that a lot of students enter cs2c who haven't done the proper route of mastering 2A and 2B material first. Just land into cs2c thinking that, well, I've programmed and I've got the clearances from these, reputable places, or I'm a prodigy, and so I got my prerequisite waived, and so I can do my cs2c. Okay, suppose hypothetically, if that is an attitude, they don't really know cs2c, they're going to be thinking in C++ when they are looking at cs2c level problems, and that is a big hurdle. So that is like, that is why even when you interview people for a programming position, and you're interviewing someone, you don't care what language they're going to solve the problem in. Well, I don't know, maybe you haven't, interviewed, or you haven't been in interviews. You'll find this is the case, okay? When you go to places and interview, most of the really solid programmers don't care what language you use, right? Because they don't care. Even if you use English, right? You mix with English and Russian and Chinese and C++ and mathematical jargon, everything together in a mush, as long as it is precise and coherent and pointing to a single idea that both of you can identify and zero in on simultaneously. He doesn't care, she doesn't care, I don't care, right? And you don't care, yeah, because it's the communication of the idea that is important. And so when you enter CS2C or 1C or 3C, if you enter it with the assumption that, okay, now I'm just going to show people my mastery of the language, right? I'm so solid in C++ now that I can do CS2C, that is a failure to really grasp the core of CS2C or 1C or 3C, because at that level, you're not dealing with the language anymore, yeah? And so that's like majoring in Shakespearean studies and being asked, can you write a grammatical sentence in English, right? And so anyway, so that's what it is like, I think. So we can start coding anytime we want. So this is my plan for today. What we'll do is, if I'm not mistaken, what did we do last class? Actually, remind me what we did last class. Hey, Keenan, or anyone who can pick up Van's link. I think he posted it somewhere. He said on Reddit. I don't know, right? Or maybe Canvas. I don't know, more likely on Reddit. Okay, so if you can pick up the code, let me try and remember what we did last class. If someone remembers, let me know. Okay, we coded. Oh yes, heuristic search. Okay, yeah, heuristic search. That's what we did. Okay, some funny search technique we came up with. Obviously, nobody was interested enough to pursue that anymore. Okay, so I'm just going to leave it at that. If somebody had actually taken, more interest in it, then okay, yeah, it's okay, fun. It's fun to take that to the next level and see what more we can extract out of it. But it's now there as a dangling fruit. Anyone can take it at any time. Does not have to be during class time or even the course time. Just pick it up and noodle more on how this heuristic search can be improved. What are the different kinds of heuristic searches you can improve? And like Kaylee said, well, if I have to search a large vector, and I've been told that there's some kind of pattern to this vector, let me see, instead of searching 1 million elements, I can put in a fixed cost of, let's say, fixed cost of 100,000 elements, right? So I'll just look at the first 100,000 elements and see if I can discern a pattern. Yeah. And then once you've discerned the pattern, actually, I don't know if very long, this is more than a decade ago. I don't even know if this site is still active. Someone should pick up Google and in a browser, type in interesting mathematical series, okay? And some guy at AT&T Bell Labs, I think, right? And I think I'm remembering from more than 10 years ago, okay? He made a list of every possible mathematical series known to humans, okay? And it's documented on a website. So in fact, if you have some strange series in your mind, someone says, 1, 3, 9, 27, 2, and 14. What is the next number? Okay, and you have a hard time figuring out what the next number is going to be, just type it in there into that series, right, into that website, and tell you, well, this is a mathematical expression. You know, you just plug in the values 0, 1, 2, 3, 4, and 5, you get these numbers. Okay, and and for any known weird and wacky sequence, that website tells you this is a mathematical. I think so. Okay, because I had a lot of fun.
Wait, what's the site called?
Just Google. I think it's called Math Series. I think it's Math Series Encyclopedia. A Math Series list of mathematical series. List of mathematical series, and I think it is in AT&T Bell Labs. Okay, I'm pretty sure. If it was there like 20 years ago, I'm pretty sure now you even have a JavaScript version of it somewhere. This wasn't even it wasn't even you know, an active page. It was a static page just listing all the functions and links. Okay, did you find it, Sean? Were you looking for it? Who's got a web who's got a, you know, a browser they can share? Can someone share a browser? We'll do a search.
I'm looking for it, but I can't find anything.
Yeah, can you Google? Okay, hey, Kenan, is it possible for one of you to share your screen?
Does somebody else want to share today?
And anyone else? Yeah.
Slow.
Ashwath, are you near a computer? Can you share your screen? Sean, Kai.
Yeah, I mean, my school Wi-Fi is also really choppy today.
All right. How about, well, here. I'm going to share my screen. Okay. I won't be able to see. I'm gonna share my screen, and I'm gonna see if I can have a gallery and my screen. Okay. Yeah. Okay, I think it's possible. Yeah, I'll share. Okay, so what I'm gonna do here is I'm gonna, oops. Okay, so I am going to I'm gonna open a Chrome window first. And I'll do that incognito mode thing. Okay, well, it's for Safari, it doesn't matter. Okay, and yeah, okay. So what do I need to do? Where's my Zoom con now? Oh, here. Okay. All right, now I'm going to share my Safari. So in that case, maybe if this works out, I'll just do the coding today too. And if it's too fast, you get one of you should. Ideally, I'd like one of you to code. Okay. So all right. So can you guys see my Chrome window? I'm going to reduce the
we can see Safari window.
Well, I mean, there's nothing in there. It's okay. I'm just
it's just like a home screen kind of.
Okay. All right, so I'm just positioning things so I can see you guys also. Okay, so I can't see all of you, but I can see some of you. Oh, and I have to. Oh, there you go. I can actually see all of you. Oh, many of you. Hey, where's Kaylee? Are you still here? Oh, yeah, there you are. Oh, why is Zoom doing this really crazy thing? Okay, it's just choosing the number of people to show arbitrarily, and okay, okay. So this is crazy. Okay, now I've got all of you on, well, most of you on screen anyway. I can see all of. All right, so let me go. Move this guy out. Okay, so what do I want to search for? Infinite math series, Bell Labs. I think that's where it was before. There you go. This is the very first hit. Kenan, how did you say you couldn't find it? I think this is the very first one. Neil Sloan. I remember the name, right?
I didn't put Bell Labs.
Yeah.
I was just looking up like interesting math series.
Oh, it is AT&T Bell Labs. Okay, so this is from 20 years ago. Okay, almost 20 years ago. Let me get rid of Bell Labs. Okay, I'm pretty sure it'll still be in the first one hit or two hits. Okay, Infinite Math Series. Okay, well, all right. All right. Oh. Wow, it's not showing up in the first page even. You're right. But if you stick in Bell Labs, it comes up. And what are the odds that I remembered Bell Labs after 20 years? Yeah, okay, Bell numbers. Okay, so in fact, labs, let me try labs. Wow, okay, all of those words. This is so interesting, isn't it? I have to put in all of those words in order to get the first hit. And this is the one that I was talking about. So it gives you a pattern. It gives you a pattern, and you just have to type in any sequence, oh, wow. Well, the interface has changed. 20 years, that's the least you can expect, okay? 20 years ago, you could actually go in and type in the first 5 numbers or something of the series that you have in mind, and it'll tell you what series is and what the next few numbers are. I'm sure it's in there somewhere, okay? I think that's what it is. The OEIS, I think that's what it is, okay? There you go. Yeah, someone's typed in those numbers and they're hitting enter, like, you know, Wolfram. Oh, anyway, so what does it do, right? So the interesting thing here is that, well, is this AI or machine learning, you know, it's not even artificial intelligence, artificial simulated intelligence. That's what it is, right? ASI, because you have a box and you type in, you know, 5 or 10 numbers in the series, yes? And it tells you what the 6th number is and what the 7th number is without looking into your notebook. Yes? Now, you know, various philosophers over the past thousands of years have talked about this. And, you know, most recently, I think, you know, or not even most recently, when I was a you know, student, what was it? You know, the two common arguments, Chinese room experiment or something like that. Okay, so there is a translator who knows Chinese in a room, and behind her is the entire encyclopedia of everything in Chinese, including translators and everything, right? Back and forth from English and Chinese and everything. Everything is in there. And this person can only talk in English, okay? This is an English person, and they have a translator and the entire inventory of all Chinese knowledge miraculously condensed into a room, okay? And it's in there. And this person can only speak English. And there's a person outside and asking her questions in Chinese. And this person who does not understand Chinese, right, says, okay, hang on just a second, let me think about it, okay? Well, in gestures. And then during that few seconds, she turns around and just says exactly what she was asked in Chinese to a translator. And they, utilizing the vast machinery of Chinese intelligence behind them, get the Chinese answer and give it back to this person. And this person says, okay, this is what you have to say, all right? And they say that, okay? So the question then asks, well, who understands Chinese here? Is it the Chinese missionary behind that person? Or can you say from the external observer's point of view, this person actually understands Chinese? Or from the external observer's point of view, you say, well, you know, this person and that room, they're inseparable, because if you just cut them in half, it's like cutting a human in half. Neither half is functional after that, okay? So it doesn't make sense of talking of this person anymore, because this person is now an integral part of this entity called the Chinese room, okay? Now, but that room has intelligence. It has human intelligence and the Chinese knowledge, all right? So even without a Chinese human in there, with an English human and all the Chinese knowledge, you still have a Chinese human in there. So, but the Chinese human is not functional without the Chinese knowledge. So you can't drive a wedge in there. So the question is, all right, so there's 3 different things you can say now. So what is the right thing? Is the whole unit now one intelligent organism, which understands both Chinese and English? So those are the kinds of interesting questions that, you know, have philosophers through the ages, millennia, have talked about and things like that. I'm just talking to you about the most recent incarnation that I heard when I was a student. Maybe there's more recent incarnations like of that. But the point I'm making here is that coming back to AI and machine learning. So you have this website that does exactly what we did before last class. Yes, we got a vector. And we only looked at the first 2 elements and formed our 2 equations to discover B and C. We had a little bit of inside knowledge, yes? to say, okay, it's a form, it is a quadratic of the form ax squared plus bx plus c. Well, I don't know, Giovanni is yawning and all, so I don't even know if this is all making sense. Well, you know what? Well, why don't we just start coding, okay? So what we want to do today is basically pick up the, do you want me to code, okay? If you want me to code, I can just go to coding rooms right here, and I'll say, this is what we want to do, and I'll start coding exactly what we did before, okay? And say, you know, this time what we want to do is use a linked list instead of a vector. So every time, so essentially what we're going to try and do today is build a linked list. Now, I've done this millions of times in my life, okay? And it's not hard work for me to do it, but it's not as much fun for me to do it as if you or one of you did it, okay? And I walked you through this. So rather than me code this, I would really like it if one of you could just take the chance and say, I'll just walk, it's just like me coding it, essentially. You can just be a robot, okay? And I'm gonna walk you through this. Rather than me typing it into my browser here, like you've just seen, I'm just gonna, you know, share your screen like we did before. I get more of you on screen. And I'm gonna type, I'm gonna verbally type, essentially, right? Instead of typing by hand, I'm gonna verbally type. And if one of you can volunteer to be essentially, initially anyway, you say, I'm going to type what Anand says, and then later on you'll see that you're actually typing ahead of what I say, right? Because you see that, oh, well, it's actually fun. Let me have more of it, okay? And you can't wait for me anymore. And then you start typing ahead, okay? And then you've got your own speed. And when you've got your own speed, then I can say, okay, all right, that he or she has got their own momentum now. So I can go back and, you know, work with someone else. And so that would make the teacher's job a whole lot easier, essentially, because, you know, it's more fun if more people are together in the same place, yeah, rather than having to run back and forth. Do you guys agree or not? If one of you can please take the screen, okay, I can stop sharing my screen and then go into your Chrome, you know, one of those windows. And what we'll do is, again, we can start with a blank slate if you want, okay? We can start with a blank slate. And we'll say, before we do what we tried to do last class, which is essentially build a vector within which you're going to search, today, rather than saying we're going to search a linked list, okay, forget about searching a linked list. And forget about all these fancy things you see out there saying this is a linked list and that's this. No, okay, we'll just say what we're going to do today. If you're okay with this plan, hey, welcome to class June, okay? One of you should, I was just saying, one of you should please take the screen. June, and for you too, right? Same request. If you can take the screen, let me know. All you have to do is just take an incognito Chrome window, Chrome, right? Chrome, or I think even Safari or Mozilla, whatever you want, a browser, and then go to coding rooms, and we'll just set up a project, and I'll walk you through every single step. Okay? I don't mind doing it, and the reason I don't want to do it is because I have to pay double attention when I'm doing it. The reason, what I mean by double attention is that I have to not only focus on teaching, getting the concept across, but I have to be mindful constantly that I'm not going too fast or making silly mistakes that I would normally do when I'm coding. Yes, because everybody makes silly mistakes when they're coding. And we know they're silly mistakes. And we know, yeah, okay, you know, I see that over there. I'm not going to fix it right now because that's a silly one. I can fix it later. So you do this and then go back and fix it later. Did you do that? You do that? Forget about coding when you're writing English essays. I'm pretty sure every single one of you has written an English essay, right? So you've written something really cool there, but it has a grammatical error or a much better way of phrasing it. Yes? In a scene, all right? The sun rises, you know, as a scene. And you know, okay, I know I want the sun to rise there, but I want the scene to look much prettier. So I'll go on with the rest of the story. That needs to be shot, okay? And then I'll use, you know, Unreal to munch the sun into orange or something like that, okay? So yeah, just like sentences, you go back and correct it. You do that in programming all the time. And I think that is one of the reasons why I found that our pair coding here has actually helped a lot. And in fact, Elaine used to tell me, right? And I tried her advice for a few quarters. And it didn't work for students for me, okay? So I said, Elaine said, you should try pair programming. She's retired now, okay? When I joined, she was here. And so you should try pair programming because it really works wonders in my class, okay? The students are like, super engaged and they're helping each other out and all. So I tried pair programming for, I don't know, like 4 or 5 quarters even, right? But I couldn't get it to work in the way that she got her students to do it. However, then I just realized that that's what I'm doing here. It works for me because, and I'm doing exactly what Elaine suggested. In Elaine's experiment, or the one she said worked in her class, the students would be in pairs, 2, 2, 2, 2, 2, right? And in the pairs, one person is not allowed to think, right? But the other person is, but they're going to type, and the other person is going to call out the code. And then after a while, they switch, right? So, so it kind of forces them to be a typist, but at the same time, be ready to understand what they're typing, not as they're typing it, when they take over. So they have to, and it's a very nice and unique skill, I think. And because as you're typing, also, I think what happens is that you're basically typing it in, but I think you're also staying in step to take over at any moment or something like that. And then you're able to type a step ahead at any time. And you see some nice things happen, right? If you like, you can do pair programming in class here too, because we do have an even number of people in class. Otherwise, I'm happy to, if one of you takes a screen, I'll just walk you through the very basic steps of a linked list, okay? Nothing to do with a formal linked list or anything. What we're going to try and do is essentially create a class, okay? I'm just going to go back to classes now. I'm going to create a class, basically an object. And inside the object, all we're going to do, other than the data element, right? Because we have a data element, because in C++, any language, we're used to dealing with data, right? Everything we deal with is basically a data element, whether it's a character or a number or a double or some complex object you've created. They're all elements, data elements. Yes or no? Everything is a data element, right? Now, what we say when we do objects is that I want another data element which contains some other data element. So I want a package that contains 5 integers. Okay, so that's my package. And what we're going to do is basically create an object that has a data element like any other object we create. However, it's going to have a special data element. The special data element is essentially just a memory address, which is also just a data element. Think about it, right? That is the beauty of C++. Now, in the last couple of lectures of C++, in this class, you are being introduced to the true power of C++, okay? This is really the true power, the core of C++. And you don't find this so explicitly stated in many other languages. And that's why a lot of people still love C++. Is basically, in C++, the address of something in memory, okay? The address of, so let's say Giovanni lives in, 456 Main Street or something like that. Yes. And we say your address is 456. Yes, Giovanni. So you can be reduced to a number right there. In fact, the place where you live is actually a number. So when I'm processing a whole bunch of houses on that street, I could process numbers. I could say process all the houses from 450 to 480. And your house happens to be one of them, 456. Yeah. So as a government, order to do something, yeah, and they could do that. So essentially, you're being processed as a number, but the power there comes from, I don't want to have a list of people there. I don't want to have a list of descriptions or photos of all the houses. I just want these numbers, which means I can just process them just like numbers. I can add one. So I've done 30 houses now. I can do another 30 houses next, add 30 to all the numbers. So I can process them. So in C++, we say, just like in Unix, the operating system Unix, they said, I don't care if my data comes from a file or from a socket or from a network connection or from a wireless connection, network or from outer space, right? It's still a data point. So as long as I have a point from which I can read, and that point knows how to receive from all these different sources, right? I can build the rest of my complicated machinery, right? Not complicated, really, sophisticated machinery that can deal with data, because dealing with data itself is a huge universe. If I need to focus on how to deal with translating everything into data first, okay, that's another huge universe. So I'll be, mired in a dilemma. I won't be able to do any productive work if I have to look at both, translating the data and dealing with the data. So computer science is dealing with the data, right? Maybe, another science altogether is translating the data into all the forms in which the computer can deal with it. That's digitizing the data. Yes? So we have all these coders, coders and modems and all these things that take data that's analog in nature, like continuous waveforms, and digitize it, saying, well, if it's analog, this guy can't do anything with it. This is, this huge universe of, computational machinery that can really do magic if you can give up one little thing, right? This guy can do magic for humans, right? And that one little thing is that you have to forget that you are now a continuous function, but instead you're just approximated by a discrete number of points. Now, what kind of a massive leap is that? Okay, because that kind of a leap is, philosophically speaking, practically inconceivable. Because mathematically, we're going from countable space to uncountable space. They're two different beasts altogether. Because all numbers are countable, right? Countable meaning you can put them in one-to-one correspondence with numbers. So numbers are countable. Even numbers, I don't know, this is number theory, okay? Odd numbers, even rational numbers are countable. Even the numbers, between 1 and 2, all the fractional numbers, okay? Even they're all countable. All the infinite number of rational numbers, you can have a one-to-one map between the rational numbers and integers. Even though intuitively we think there's more rational numbers than integers, you can put them in a one-to-one map. Okay. However, you cannot do that with any number of finite infinities, like discrete infinities, and an uncountable infinity. This continuum, right? Continuum is a real number, and there is no way you can form a one-to-one map. This is a true bigger infinity than this infinity. Right? And so I don't know how we got started talking. Yes. Making that leap, that is really machine learning also, because what you're saying is that continuum is reality, right? That curve, that parabola, that whatever you see out there, that's continuous and it's real. But this finite apparatus with discrete processing techniques cannot handle that. So what I'm going to do is that I'm just going to, as fast as my machinery lets me, I'm going to keep sampling that rapidly, right? And I do that, trillion times a second, whatever it is. Still, they're just data points from the continuum. They're not the continuum anymore. So what you've got is basically an approximation of the continuum, arbitrary approximation, but it's still an approximation of the continuum in the form of digitized data points. That's called quantization, right? No, not always quantization. It's basically discretization, right? So essentially we're saying I can't deal with the continuum anymore, but I can deal with trillions and trillions of individual points. So instead of, I'm just going to sacrifice the infinity, because what you're sacrificing is really infinity. Anytime you go from, the continuum to discrete, you're saying I'm going to give up my infinity, because that infinity is infinity squared, a different infinity altogether, right? Discrete infinity is just the countable numbers. You're going from uncountable space to countable space. That is the biggest sacrifice you make, right? And for that, you get all the computational power. So, so you have this thing here, and that is essentially saying you punch a bunch of numbers here, and I will tell you the continuous curve behind that. That is an incredible statement to make, isn't it? Because you're punching in a series of discrete numbers, and that is telling you, well, those numbers you gave me were generated by a continuous function of the form n cubed plus, n squared, or whatever it is, some polynomial function, right? And that's the function that generated those numbers. And then we say, well, that's probably right, because, I've tried it for 1 million numbers, I've tried it for 10 million numbers, and that function seems to work all the time. But how do you know? How do you know that it's not going to break at some point later? Yes? Interesting, isn't it? because there are a lot of mathematical functions. People have made wild conjectures and guesses. Ramanujan, for example, right? About many series, and saying this is what it is. And people can prove it or disprove it, and or find a counterexample either, because they tested on lots and lots of numbers. They cannot find a number that disobeys it. So they said there has to be a pattern, but we can't find the pattern yet. Okay. So, but obviously people don't rule it out. So there's active fields of research around it. However, Euclid, for example, is it Euclid? Yeah, Euclid, I think, is proof of the infinity of prime numbers, because that is, one of the primal problems in mathematics, because the series of prime numbers, you see that, one is not a prime number. You got 2, 3, 5, 7, 11, 13, 17. So you see, it seems to have a pattern, like, the first number, okay, even, right? Everything else is odd, but still that pattern does not seem to hold, right? Many odd numbers are being missed, like 9 is out, and so on. So you think odd numbers is not the pattern, but maybe there's another pattern. And someone says, okay, well, at least one pattern is that these prime numbers start out really close to each other, but eventually start getting thinned out, because, fewer prime numbers as you get bigger. And it only makes sense, because the big numbers have a lot of little guys who can divide them, right? Small numbers don't have a lot of little guys who can divide them, yes? So big numbers have a lot more potential factors than small numbers, yes? I don't know. Yeah, well, okay. Well, anyway, so this thing is, behind this thing. How do you know whether it's AI, intelligence, or machine learning? Meaning that they've made a hypothesis about some complex polynomial, and then they've used number crunching to determine the value of the weights, which is what we did last class, right? In class, we got this polynomial and determined the values of B and C examining the values, right? So how do you know they're not doing something like that? So because you plug in some numbers and they tell you this is the polynomial that generated those numbers, and if you generate many more numbers, that's what that site will do. So how do you know they're not doing machine learning and they're actually looking up? Because in the olden days, when I tried it, they were actually looking up, right? It's quite possible too, right? It's because they have this encyclopedia, like billions of series, okay? And it has some hash function, and when a series comes in, they just need to do some clever lookups like Wolfram does, and they say this is a series, okay? And maybe it takes them a fraction of a second and gives it back to you. So that's what they used to do, and so maybe they're still doing that, right? But however, it's possible that they also say, well, let's look at some common polynomial expressions, and then infer the values of x1, a1, a2, a3, all the coefficients, right? Maybe they have a computational power to infer, like, 50,000 coefficients and for a polynomial, and find out which one of them gives integer, whatever, right? Things like that. So it's possible, right? So how do you know? Because what we did last class was essentially, for someone who didn't know, was essentially trying to learn the function. So anyway, what we're going to try and do today is we will create a data structure with an address that points to another object. That's all. That's so simple, isn't it? Now that we know how to make objects, we're going to make one more object, which is going to give you the true power of C++, which is an object that contains an address 456 that points to another object. Okay, so rather than if I want to clean, if the government wants to clean the sidewalk, okay, in front of a certain number of houses or something like that, okay, the city council or something like that, they could say, I don't know, that's a very bad example, right? Because they have got to be in sequence. Thinking about something that would be like a chain letter. It is a chain letter, right? So let's say, go to Giovanni's house in 456, and then give him a this magic parcel or something like that, and then he says, well, the next person to send this chain letter to lives in house number 732, right? So it's not the next house, you've got to go somewhere else, and that person tells you where. It's like a chain letter, okay? That's what we're going to try and do today. So it's so easy. One object, a data item, and then a link to another object, okay? You cannot have an actual object in there, right? Obviously, because if you have an actual object, that object has to have another actual object in there. So you can't really have an infinite thing in the package. So you can only have a pointer, and that can have another pointer. And the advantage of that is that you can have really massive data structures now, right? Previously, it was limited. Your vectors on any machine, they are limited in size by the maximum size of the contiguous memory locations you can get from the computer, right? Because vectors got to be contiguous. You can't have, some chunk of the vector occupied by something else, right? But with linked data structures, you have no such limit. Because you can say, I got the first 100 items here, but then you got some junk here, so I'll just skip over the junk and the 101st item starts here, right? So you can now cover every single thing. So the moment you introduce a linked data structure into any heap, immediately it can balloon out like foam and fill all the nooks and crannies. Because anytime it sees some memory, it can allocate a copy of itself and fill that. Yes? But a vector can't do that. And the reason to pay special attention to the linked list and the vector is, if there's, how many of you have played chess? There's, I hope you all know the game chess. Yeah, chess, Go. Not so much, Go, more strategy, okay? I want to talk about chess, which has slightly less strategy, but more, you need to know more knowledge and skills. And I think, right, I'm not a Go expert, so I don't know. In chess, I'm not a chess expert either, but I know that enough of it in chess that every single piece has its own strength. Even a pawn has its own strength. Yes, because in certain situations, a pawn can be your worst enemy, right? I can win you the whole game. And your knight has very limited power, but extremely solid power in certain situations. Your bishop, your queen, right? And your rook, and they all have unique powers of their own, yes? Now, the thing is, you have to play chess for a very long time. It's not enough to know that, this is how they move. Because everybody can, you can read a book and find out how the pieces move, yes? But and then you can say, wow, okay, a queen can move like that, must be really powerful. Bishop can go all the way like that, that must be really powerful. You can learn all these things. These are special skills. But the only know how to play chess properly and enjoy the game when you know the real power, when you feel the power of these unique capabilities, right? So you know that a bishop can go like that diagonally, right? Not into diagonally, right? So a bishop can go like that, right? And a rook can go like that, okay? That's all fine, but you got to play like a million games, whether in your mind or against friends and other people. You got to play lots and lots, because when you play lots and lots, you encounter situations in which you will see a knight being used that you've never encountered before. Even though a knight moves like an L, like that, right? You would not have encountered a situation, like millions of situations. One situation, right, in which a knight is a particular position where it basically makes, yes or no for your game. And you only end up in that situation by playing it, because that situation by itself is not worthy enough for a grandmaster to come and tell you, pay attention, man, that's really good, okay? You got to understand that. No, they don't do that. So they just say, keep on playing, keep playing, so that you encounter all these nooks and crannies and fill them up. And like that, a linked list has powers. It has powers like a knight in chess, because at the moment it finds a gap that it can go to, it'll go there regardless of anything in its way. Yes, a knight can jump over pieces, other pieces, yes. But a rook is like a vector. It can grow as big as you can, right? And it's really powerful in many ways, but it can't get past an obstacle. So in certain cases, getting past an obstacle is not as important. In certain other cases, getting past an obstacle is all the difference. So then a grandmaster knows when each piece will be more important. Does that make sense? I don't know if that analogy works. Okay, that's how it is when it comes to C++ programming of any kind, is that it's not enough to know that there are these data structures, right? A list behaves like that, and a vector behaves like that, A vector is definitely better, list is definitely, no, that's all nonsense, okay? Even people who say C++ is better than Java, total shit, okay? Everything has its own power. The real programmer will know the power of each one of those guys, and no, this is in this place, you should have a C++ program, right? Why do you have a lame ass Java program then? Okay, because you already know the algorithm, you could crunch it all the way down to the machine code. Why do you have an interpreter in the middle? So you can ask these questions because you're not looking at individual languages anymore, right? So you can't say this is better, so you have to say, and so you can't say a linked list is better than a vector. You got to know the power. That is why you spend a lot of time learning the easy pieces first, which is your vector. It's like the rook, very easy to learn its power, because anything in its path, it's just smashed to smithereens. Okay, it's got a power. So learn the vector. Okay, and then after you learn the vector, then you try to learn, the bishop, and then the linked list. Okay, so you can just grow everywhere like that. Okay, but it can't be like the vector and be fast and things like that. I think that is a great analogy to how you can master computer science itself, because once you know the power of these things, you can put them together in the right order and the right places. Yeah, all right, so that's enough of a spiel from me, and you guys are being so way too patient. And of course, the goal is to eventually transcend chess. Okay, give up the idea of skills being isolated in each of these different things, and go to just pure strategy and go, right? And say, I don't care about this being able to move in that particular way and this being able to move in that particular way. As far as I'm concerned, everything is equal. Everything moves in exactly the same way, right? What is the strategy you can get out of that now? Okay, now you say, I don't care about, the knowledge. Knowledge could change all the time, depending on how things, the society determines what is right and what is wrong, okay? But if the strategy, the logic, what you want out of life, what humans want out of life, that's always going to be the same, millions of years into the future too, right? As long as we're conscious. So let's abstract out at this level and look at, forget about the individual skills or the individual things and say, what is it everybody wants? Okay, so that's only the strategy. That's all crazy, making these long-range connections to, but I think the analogy is very solid here, because, when you get to 2C level, you should not really care about individual things, and you say, this is a problem I want to get solved. How can I solve it? If in fact a linked list can be better than a vector at a certain place where usually people use vectors, I would use a linked list, right? So, but you won't know that. You won't know that until you've played enough with linked list to know how flexible it is, right? If someone gives you a brand new material and say, use this in building your home, you're going to say, where can I use it? I don't know. Is it going to break here? Is it going to break there? No. But if someone else who says, I've played with this material, this kind of foam for 10 years, I know exactly where it can go, right? Then you say, all right, I want to build my house using that, okay? Because you know its strengths. So that's why, even if it's not for an employer, even if it's not for me, even if it's not for something else, you got to find interesting problems to code, okay? Even if it's not for something you're going to share with other people, doesn't matter. Over the spring break, don't go to a beach, okay? Just stay at home, get familiar with linked lists and vectors, okay? Because these are the two important pieces in chess, in computational chess, right? And because if you know how to wield them, wielding a queen is easy, right? Because these are very knight and the rook, okay? Vectors and linked lists, and everything else is comparatively simpler, okay? Well, there's also techniques like recursion and things like that which you have to master, but that'll come later. But knowing how things are packed together is like the crucial part of C++, and once we get past that, it'll be absolutely fantastic, because we can then start talking about things without having to rely on language, right? We don't have to say, well, implement that using. We just say, all right, so that needs to be some kind of a linear process there, because obviously I think so. Can you do it in constant time? No, it can only be linear, like that, right? So that kind of conversation, because once you get to that, it doesn't matter when you're talking to someone whether you do it in which language, okay? Hopefully, you're not far from that, because you're already doing cs2a in less than 2 years, if you put your mind to it, okay? If you set your mind to it, you can get there in less than 2 years. Maybe some of you are already there if you're just here to pick up the language and how to see, right? But this is not hard to get. That's what I mean, okay? just to get past it. That's what I mean. Getting past it, getting past the language aspects of it, and getting to the thinking aspect of it. That's the fun part. Okay, so is everybody okay with this? Would someone please like to share their screen with a Chrome window, and then what I'll do is we'll just create main, and inside of the main we'll just create a class. We'll create a class with an object with a data item and a pointer to another object of the same type, and then in main we can create lots and lots of objects like that and link them together. Okay, we'll play with it. No plan. We're just going to create a free form linked list and play with it. That's all. Okay, and we'll play with it as we usually do in class. People can talk and say, do this and do that, and we'll do that. Okay, so if you guys are okay with that, can someone please take the screen if you don't mind? Can I stop sharing? Nobody's even talking. Okay, I don't even know if you guys are paying attention. By the way, there's only one more week to go, right? And then it's a final exam. Are you guys interested in this kind of thing at all, right? Because most of you are passing. I'm pretty sure you're all passing class, okay, by just being regular students and putting in the work. Because I don't know if you're really interested in this, or I should fuel you up in any way to prepare you for a career in computer science or cs2b and advanced research and things like that. Because if it's if you're just here for getting to know it, you already have it, where you don't need to even come to class. Because my assumption is that, because even on Reddit, it doesn't look like you're passionate about this from the looks of it. But if you're not passionate about it, you're good already, because you've got what you want, right? Because most of you are passing class. I can guarantee that. Because unless I haven't, because I saw that in Canvas, the quest scores are missing for some of you. Okay, even the ones who are regular, quest scores are missing. Someone reach out to Noah, I don't know, and let him know. But many of you maybe don't care about your actual scores, and you're just here to have fun and learn about C++ and things like that. That's okay with me, and that's consistent with your behavior, saying, well, I don't care about Reddit, but I just want to come to class and have code from time to time and have fun. That's okay. But being really passionate about it is different, okay? Because you say, I want to learn this, with a fire, and then you'll have my entire support behind you. Because if you really want to learn it, I will help you. But if you don't want to learn it, I don't want to. It's no fun for me to shove it down your throat and say, well, you got to learn this, otherwise I'm or else, right? That's no fun for anyone, right? Not for you, not for your parents, not for your teachers. Nobody likes to do that. So all we're trying to do is make it fun for you. And in order to do that, you got to keep telling your teachers all the time whether what they're trying to do is working or not, right? Sometimes when I just go off on a spiel like this and talk about series and math functions, and you say that's totally not relevant to cs2a, dude, cut the crap and start talking about cs2a, I'm more than happy to do that, right? So so why is it that nobody wants to why is it that everybody is feeling reluctant to code today?
Personally, for me, my internet's just been going out every minute and a half. So
right, Keenan, yeah. And also someone else said that too. But nobody else is even offering out.
I'm just a little behind on the readings and stuff. So
but Kai, if you have a decent connection, that is perfectly fine. Because what we'll do today is going to start from an empty slate, and then I'll be walking you through every single character you type. So you can basically be in blind mode too. I've told you that before, right? Anyone who takes screen can be in blind mode, because you'll just be doing me a favor, or doing my wrists a favor, because I have this RSI thing where if I start typing for more than 10 or 20 minutes at a time, then it starts playing up. So I try to minimize that. So you can just be my typist, and I can call out the code you need to type.
I can share today.
Thank you.
It won't let me until you stop sharing.
Oh, I'm sorry. Sorry. Okay, there you go. Now you should be able to pick up the screen. What time is it, by the way? It's 9. We got almost an hour. Okay, and in fact, I'll turn the screen over to you guys at some point, and you guys can all code too. I think that's Fine. Whenever you guys are comfortable. Okay. Let's can we create a brand new project? Yeah, you create a brand new one. You can log out and log back in if you want, Kai. Or I mean, you can stop sharing and share later if you want. Yeah. Sorry, I should have told you that before. I hope you didn't have any personal information show up. If you did, let me know and I'll edit the video before I put it.
I didn't have anything up there.
Okay. Hey, Giovanni, I noticed have you completed already, or you're close? You're close to completing all 9 quests.
I'm close. It's just that I'm kind of having a hard time. Last night I tried to save it and then I moved my program file and then something happened, so I can't get it working anymore.
Okay, well, but you have got a lot of time because you got 3 weeks left. Yeah, you got 3 weeks left.
I should be able to.
Can you, Giovanni, and also other people? Okay, June. I don't know who else is close to completing. Okay, can you please help all the other guys? Okay, because they're not responding to when I say something. Maybe it's because prof or teacher or shit like that. Okay, reach out to these people. Discord, Slack, whatever the hell it is. Okay, help all these guys go to the finish line. Okay, because it's absolutely no fun. Absolutely no fun. Even if you're not planning to do my 2B or some other 2B, if you did a course and didn't get anything out of it, it's totally not fun, because you're going to have to repeat the whole damn thing anyway. Anyone who goes on to do, anything in data science, please help. All right, June and Giovanni, I've mentioned this before. I would love to help, but nobody's, taking up my offer of, so please do. All right, thank you. Thank you, Giovanni. All right, IO stream. Let's go to the top. Hash include. No, actually, we don't need a hash include. Okay, we'll do something really cool here and simple using namespace. You just using namespace. Standard. Yeah. Okay. And you notice that and one of the advantages, semicolon after that. So one of the advantages of doing this, really, also I find. And I might be wrong, is that when I talk and you type it in, is that it just builds practice and muscle memory, right? Even if you're not consciously thinking through this, you just build some muscle memory, okay? So when you open like a piano or something, so when you open the code, the window automatically will start typing, okay, hash include, and you fill in the template while you're talking to your friend, yeah? So that kind of thing will become automatic, and it's better to have a lot of these little things, right? 10 or 15 at least by the end of cs2a in your muscle memory, like basic for loops, the template of the whole program, the hash includes, while loops, all these in your muscle memory, so that when you're thinking about problems, you can say, okay, bam, 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 bam. You can slot in these bigger pieces. And cs2b, by the time you're in the middle of cs2b, you'll have bigger pieces that will be in your muscle memory, right? Like searching a linked structure for something, right? Or finding the length of a linked list, finding a length of strings, and by the time you're in 2C, even more complex algorithms, like searching sorting a vector, or sorting a list, right? Merging lists, searching graphs. All of those will become, basically your toolbox, which you start off with. you start with a small box right now. I was telling my cs2b students yesterday, the small cs2 C++ toolbox given to you at the end of cs2a, which will contain your basic Lego pieces, like, for loops, do while loops, and so on and so forth, and integers and so on. That's the control structures. 2b, you get given slightly bigger toolbox, which essentially is your 2a toolbox with commonly used things already put together for you, so that you don't have to open your toolbox and put the common things together. Yeah. So you get a bigger toolbox. You get to carry around a professional level toolbox. cs2c, you get even slightly bigger. And after that, I don't believe I know. There's not a great deal of specialized toolboxes after that. Even highly specialized engineers are happy to just go around with a minimal cs2c toolbox. Okay. Especially they're reluctant to make their toolbox bigger. They keep it minimal so that anything they want, they just build out of these basic blocks. They don't go buy these fancy things and say, oh, right, I'm going to go around with this fancy B tree from IBM or Oracle, right? They basically say, I have the basic structures and I build what I want on the go. That is an insight that I learned the hard way when I was a student like you, because I remember going, this is back in India, I was going to a math exam and a physics exam, not science, math exam, physics exam. Very early days when I started, discovering the science and things like that. And I remember, all these crazy, cool things happening. And these guys have formulas that work things out. So let me remember all these formulas. So I remember that I went to this exam memorizing all these formulas and how to, the force component, projecting with a sine theta, and f cos theta, f sine theta to get the components and so on. I memorized those and go, and I never actually got the hang of it, right? And I used to do poorly at these exams. One day, there was a very intelligent student, and his name was Jagannathan. Right? I remember when I was even younger than you, actually. Gopal Krishna, I don't know. Right? Yeah. So he told me that he remembers none of those formulas, and I told him, "This is how you solve it." He said, "No, I don't remember any of those." And he always comes out of these exams, acing them. And he never studies, as far as I can tell. He's just hanging around, fooling around, but and he never remembers any of the formulas. But he comes out. So, but I told him, "This is how I do it." Well, how do you do it? And so I never remember any formulas. That's how I do it. And he said, and I said, if you don't remember any of these formulas, how do you solve these problems? And he said, I don't remember it because I just, figure out how to do it on the fly. And he said, if I want the component of the force in that direction, I just take the cost of the angle and bam, I get it like that. So, and he said, so at that moment, in the next few days, all the thousands of formulas I had painstakingly remembered started evaporating because I said, I can free up my memory. I don't have to remember all these individual rules because I know the overarching principle, and I can do it the way that this guy does it and say, this is where I want to go. So at any point in time, I just have to take the component and calculate it. So I do everything on the fly. And this is like that because you will learn how to, I don't know how I was going with that. These components, yeah? Remember all these, instead of formulas, you say, well, I want to put it, yank it there and put it. I don't know how we got started talking about that. I'm so sorry. All right, let's go above main, above int main, and create a class. And we'll put a comment there saying what we're going to do. All right. Put a comment on line 4 saying also today's, well, you don't have to take today's date. In this experiment, we're going to create a single linked data structure. And then in parentheses on the next line, you can say, to give an analogy metaphorically for other students on the next line, you can say like a single bead in a necklace, right? In parentheses, you can say like a single bead in a necklace.
Single bead.
A single bead in a necklace. And NECKLAC, right? And on the next line, you can say this data structure will have this class will have an integer inside it and a pointer, which is an address a numerical address on the next line, yeah, break, yeah, which is a numerical address, right? Address of another similar object of the same class. Somewhere else in memory, potentially somewhere else in memory. Oh, it has to be somewhere else in memory, right? Somewhere else in memory. On the next line, you can say somewhere else in memory. Thank you, right? And then I want to change on line 6, where we say this class will. I think we should say an object of this class will. So maybe we'll say this object will, so that our line length doesn't change. Yeah, this object will. Yeah, this object. Yeah, does that make sense to everybody? Okay, this is the fundamental unit. Okay, once you understand this, linked lists are a piece of cake. Okay, because if you don't understand this and then learn linked lists, saying, okay, now I'm going to do linked list quest number 9, right? Where, you know, successes and predecessors and things like that, you're sunk right there. Okay, you can't make any progress. But when you understand this, which is like 5 lines of code, right? This is the basic building block. All of that, quest 9, you can do in your sleep. Does it make sense? Okay, here's what we're going to do. So say class space node. Okay, node is a very common name that programmers use, and say capital N for node because it's going to be class like in Java, right? Capital node, yeah, NODE, space, open brace.
Yeah. See.
Fernando, your microphone is on.
Okay.
All right.
Yes,
so
sir.
and then put the closing parentheses on the next line and make some space between them so that we can start filling in node now. Yeah, and put a semicolon after the closing parentheses. Again, habit, right? Habit, and then, you know, doing that, like just because I told you, on your own also many times, just make that muscle memory. Okay, semicolon. That's your template. Anytime you do a class, put the class word there, name of class, brace, semicolon. That's just like your main, right, of a class. Bam, like that. Okay, that's how we start. Okay, so in there, we're going to say this class, let's start off this class with all public for now. Okay, so let's say all public, everything in this class is public. Okay, just say yeah, for now, let's put a comment saying, for now, let's say everything in this class is accessible by everyone. For now, everything in this class is accessible by everyone. Yeah, okay, on the next line, you say public colon. That's what the word means. Public colon means everything following me until the next declaration is accessible by the public. Okay, so on the next line, you can say enter. Yeah, enter. Yeah, so Java programmers would do what, you know, Kai just did. It was basically say public and then hang around on the same line. Because Java, you say, you know, that's the way you do it, right? You say public and private before every method and variable. In C++, you just say it once, and then you can qualify a whole number of guys after that. So we put it on a different line. So, and also the other convention in C++, common convention is that the word public is now lined up against class, not with the rest of the. So you can put the word public all the way to the left, line it up, yeah, and take the comment and put it above node, right? So that, or you can put it against public, right? Public colon, and then you can put the comment right there. Yeah, that's fine too. That's fine. However you feel it looks good. Okay, now you can indent in and say int data. That's my data item. Yeah, semicolon. On the next line, you're going to say, this is a special thing, and it'll take you a few days at least to get the hang of. Okay, that's why I don't want to introduce too many concepts here. We will introduce 4 more concepts on Thursday, but this concept will take you at least a couple of days. No matter how, I think, right? Even if you have experience in other languages, I think getting the hang of the star notation as not a multiplication operator, contents of, and it's a numerical address after that, that takes a little while getting used to. So you have to force yourself to discover problems, toy problems, even things that are not going to work. Doesn't matter if it's not going to work. Even if your program crashes, that's fine. You got to get into the habit of using star many times, okay? Because that makes it ingrained as a habit. Now that's what we're going to do here. You say node space. Yeah, and then it has to be capital N, because now we're referring to an object of this class. Now here's a strange thing. Now node, we haven't even defined node yet, right? Node we haven't completed so the compiler doesn't know that there is a class called node. Yes, because you haven't completed the definition yet. We're still in the process of fleshing it out. Yes.
Yeah.
But the funny thing is, the compiler lets us do something really wacky and crazy here. It says, even though I don't know how the entire node is going to look, you can tell me that there is a pointer to another node in here, and I will accept that. Now, how cool and crazy is that? Okay, because it takes a little mind-boggling leap to completely understand that. Because you cannot have an incomplete object inside of an incomplete object, right? Because if the object is incomplete, you don't know what it contains an incomplete object, right? The other object is not complete until it's a recursive infinity in space right there. Yes, you can't have a complete object there. However, the compiler says, even though the object is incomplete right now, you can tell me that it's going to contain a pointer to another node, and I will accept that. Okay, so that is something unique in some of these new programming languages. Not new, right? Ancient, right? This concept of a pointer, it takes you to a whole another level. Okay, so you say space star. Okay, star. The star will say it's a pointer. Don't worry, it's not a complete object. It's a pointer to another node. Even though I haven't told you what node is, it's a pointer to another of me. Okay, star, and you say next. And conventionally, we attach the next to the star so that you say star is a unary operator on next. Yeah. Okay. Star next and semicolon after that. That's it. Believe it or not. So that is your entire node object. So go on to the next line. Okay, yeah, clean up the blank lines. And in your main, that's it. And in your main, you can go into your main and get rid of the hello world, right? And then instead of hello world, we'll say, oh, you want the return 0 because you're going to have to put it in anyway. Yeah. Right. So up there, you can say, let's create a node. Let's create a node. Right. So you can say, let's create a node. So put a comment there saying, let's create a node. Yeah. And on the next line, you can say node, my node. Right. Node space, my node. Just like int space, my int, you can say node space, my node. Yeah. Just to give you, a warm-up exercise. Say, hey, node, there's nothing to fear from node. It's just like integer and character. Okay. So, and the next line, you can say my node dot data equals 10. You put a bunch of black lines so that you can, indicate that you're going to do a lot more there. Okay. Yeah. So, oh no, you can do that right up above the return can be down there. Yeah. And you can put the my node. Yeah. There you go. All right. So. And then, yeah, my node dot data equals 10 or whatever number you want. Okay. Yeah, semicolon, and you put spaces around this. Yeah, equals. Yeah, there you go. Yeah, there you go. All right. And then my node dot next equals null, which is a null pointer. Null pointer. Okay. And then null in uppercase, right? Next equals null. Okay. Or you can say nullptr. That's also 0. Yeah, that's fine. No. Okay. And then you can put a comment there saying null is a special memory address equal to 0, used conventionally used to indicate an invalid pointer. Conventionally, convention, T-I-O-N-A-L-L-Y, T-I-O-N, get rid of, yeah, T-I-O-N-A-N-N. And yeah, oh, you got it all. I can't see clearly, right? So used to indicate invalid pointers. Yeah, does that make sense?
Yeah.
Okay, now let's print out our node. Let's print out our node, right? So on the blank line and say blank line, let's blank line and say let's print out our node. Now you got to follow every single word of what Kai is typing, because at the end of this exercise, I'm going to leave it in your hands to create something that is building upon all of that. You're going to have to create a necklace of 100,000 nodes chained one after another. Okay, I'm going to show you how you can create small necklaces like that, but you're going to have to create lots and lots of links like that. So that's I'm going to leave in your hands, a self-coding exercise at the end. Okay. All right, let's print out our node. Hey, say cout. Yeah, and then tag it with node.data equals within quotes. You can say within quotes, you can say node.data equals. Yeah, it's actually it's actually my node.data. Sorry, my node.data. My node. Yeah. Equals, and then left shift again, left shift. My node.data. End up. Right, and then you can do the copy paste the whole line and do next also. Now, when you print it out, when you run it now, right? When you run it now, you'll see that next is actually 0. Yes, you can run it now, and you will see that. No, you got to say no. Now you got to change the second one to data, from data to null. The data to next. Yeah. Okay. Now run it. You'll see that my node next is yes, because we set it to 0. Null pointer is 0, isn't it? Now try to access that null pointer, right? Try to access that null pointer and say, here, let's do this really cool thing. Now let's go back to your code. Go back to your code. Now let's do this one interesting thing here. Go to the end of line 27, hit enter one more time. Let's print out our node in a slightly different way. Let's print out copy the whole same thing, the whole 3 lines, copy the whole all 3 lines one more time, and then add one in a different way after that. Yeah, and then we want to comment above that saying let's print out our node in a slightly different way. Right, and put a blank line above that so that it's we're going to try lots and lots of different things, right? Now instead of my node dot data, you say so on the next line after the comment on the next line enter. You say enter there. You say node capital node NODE space star P equals address of ampersand. No, ampersand is the address of operator. Yeah.
Sorry, which one was ampersand?
Ampersand is shift 7, I think. Shift 7 on my keyboard. It's shift.
Sorry.
Yeah. And then my node. And in a comment, you can say P is now the memory address. P is now the memory address where my node is stored. Is everybody okay with this? Right now, every word I'm saying here is not fluff. Okay. So if you got in the habit of
do I need a semicolon for this?
Yeah, that is correct. The semicolon. Yeah, thank you. All right. Now, instead of my node.data, you say P arrow data, and also inside the comments. Yeah, P arrow data.
Like that?
No, it's dash, and then greater than.
Oh.
Yeah, I have funny C++ syntax, but it's actually very useful. Yeah, P arrow data there.
Oh.
And the same thing with the next one also. P arrow next equals. And you'll get exactly the same thing, right? Print it out again, and you'll see you get the same thing as before. Right? Run it. Yeah. Everybody happy, satisfied that so far we haven't taken a misstep. Okay, so that's correct. Now let's create one more node. Okay, let's create one more node. saying, and say this is my node 2, right? And set it to my node dot data equals 20 and my node dot next equals null.
Should I copy and paste again?
Yeah, you can do that, totally.
So it was my node dot what?
My node 2, right? Is it, did you create a new node? Oh, you got to create a new node, right? After
Yeah.
the, yeah, this is my node 2, right? So you say node space my node 2, node space my node 2, node space my node 2, semicolon. Okay. Did you do my node space my node 1 first? There you go, my node, that's fine.
Yeah, at the top.
So you can do the same thing, except it's 20 and null now.
Okay.
Thank you for typing here, Kai. It
No
is
problem.
very useful for me as well as the other students. And make it 20 instead of 10.
Okay. And then would I fill out
And it's got to be, yeah, my node 2 dot data and my node 2 dot next. You got P arrow, right? Remove that P arrow and change that to my node 2. My node 2 dot data. Is everybody okay, right? It shouldn't just be me and Kai, and Kaylee is nodding her head, but is everybody okay with this? Yeah?
Yes.
Thank you. Hey, Noah, your quest scores are all missing. All right, I just wanted to let you know. I didn't know if you're doing it for the scores or not, but you got to take a look in Canvas. Okay, so my node 2 dot next. Now you run it again and run again. You'll see that my node 2 is 20 and right. You got it right. Now here's what we're going to do. Here's the funny thing. Now let's on the next line after 40, hit enter a couple of times. Let's link up my node 2 and my node 1, right? Let's link up. By having my node point to my node 2. All right. And the way you do that is simply saying my node dot next is not null anymore. Equals address of ampersand my node 2, right? Semicolon. Now copy and paste that, you know, the first one where you print out the contents of the first one. Yeah, print it out. Run, yeah, now, yeah. There you go. Okay, my node 2, yes? Now let's try one more thing. Let's try something even even bolder. Okay, even bolder. These are all bold steps. Okay, we started off with simple steps like this. Now we're taking a bold step, saying, all right, now we want to take a longer step. So we're not going here. We're going here by skipping like that. Yes? Yes or no? Okay, we're going to take one small bold step. Okay, one small step for mankind, right? One step. Now we're going to skip over this guy and go to the next one. If you can do that and you're 100% comfortable with that, you can skip over any number of guys. Okay, so here. Now let's what are we doing now? let's print out node 2 through node 1. My node 2 through my node 1. My node 2 through my node 1. Now this is like, you know, dance, you know, ballerina or tightrope walking. You got to be really careful, because this step you got to master like totally and get comfortable with, because thing is, when you're reaching through and handling something, It is essentially like handling radioactive material that you cannot see through a robotic arm. Because you can't see what's out there. You're reaching through a node and manipulating a pointer out there. So when you can get the hang of it and start feeling as comfortable with that, then you can be sure that you'll be comfortable with an arm no matter how long. It'll just snake through and do what you want. Okay, so let's print out my node through my. So here what we're going to do is copy the 44 and 45 and paste it there, and we're going to change a few things around. Okay, now you're going to say my node dot next dot next. Stay in step with me, okay? Arrow, 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 next dot arrow data. No, next arrow next. You had it right.
Oh, okay.
Arrow next. Arrow data equals. Okay. All right. Do the same thing on there too. Yeah. There you go. Exactly. There you go. Put it there. Okay, and the same thing here. Actually, this is a fantastic, linked list lecture, I think, because previously I used to teach linked lists in a different way, by going into linked lists and things like that. I think this is a much better way of getting the hang of linked lists. I'm going to try it one more quarter, next quarter maybe. Run it now. You'll see that you get node 2's contents. Oh, gee, what the hell is going on? Oh, dot next. Oh, I'm sorry. Dot next arrow data. Dot next. Oh no. On line 49. Line 49. No. On line. No. That is correct. On line 49. Data. Yeah. Change the two datas into next.
Oh.
Oh, even here. You got yeah. Next. And here also on inside the quotes also next.
Oh.
Oh no, yeah, one more.
Oh, it's 3 next.
Yeah, because you can't see data is not a pointer. Yes, data is not a pointer, isn't it? Data is not a pointer. Next is a pointer. Data is a pointer. Data is not a pointer. Yes or no? Data is just an integer.
Yes.
Yeah.
Next is a pointer. So data does not have the next. It's not. It cannot be dereferenced. You cannot go inside of data. You can only go inside of data to get the integer. You cannot go inside of data to get a dereference to something else. So a data item does not support the arrow. The arrow and the star only apply to pointers, meaning to room numbers or addresses. So data is not an address, but the next is an address. That is a crucial distinction between the two. Okay. So now it'll compile. And you'll get the contents of. Did you what? No. Wait a sec. Oh no. I'm sorry. Next arrow next, not next arrow next. Oh, I'm sorry. We got one too many. I think. Next. No, next data is correct. Next. My node dot next. That should be 0. That should be 0. So that should be the second node's. Oh, how come we have 3 here? Hang on. My node dot next is my node 2. Please follow me and tell me if I'm off by even a centimeter here. Okay. So my node dot next is my node 2. Yes or no? Okay, give me some feedback. Okay. So otherwise, I'll just continue thinking ahead at, I'll debug it myself. I'm trying to debug it with you. So please give me some feedback. Okay. So I lost track of where I am right there. Okay. Right. So yeah, there you go. All right. Good. No, there. Okay. My node dot next is my node 2. And then it has a data. How come we're going my node arrow next? Arrow next, arrow data. So my node not dot next, arrow data is what we want. So yeah. Okay. So we got one too many nexts here. Get rid of the 2. Yeah, right. Get rid of one of them. Thank you.
on
I
the
don't
same
know. I
line.
missed that in the first time. How did I miss that the first time?
Should I do
Yeah,
on
get
line
rid of,
49?
yes, I say same, all the way. All right, so let's make sure that we're all on the same page. My node dot next is my node 2. Yes, right? So my node dot next arrow data is the data of this my node 2. Arrow next is the next of my node 2. Yes. Now if you run it, you should see 20 and 0 and no core dump and all. Yes. Now I don't expect that this will be 100% clear to you already, but those 4 lines there, 3 lines, okay, or it's just this entire program. I don't even want to spend more time on this now. What time is it now? It's 9:41. You got 10 minutes to play around. I don't want to go to the next step right now, but I'll say in comments. But we can pick this code up on Tuesday and do the loop, right? So on comments, create a for loop. Oh, actually, we'll do one more thing. Okay, we got 10 minutes. We got one more thing. Okay, we'll do one more thing. Now, the past 2 nodes were created on the stack as local variables. The previous 2, right? Not past. So let's say previous. Create on the stack. Let's do the same thing on our relatively unlimited heap space, which may potentially be fragmented, right? Relatively infinite heap space, yeah. Okay, on the next line you say, no, on the next line you can actually say node star q equals, uppercase n, equals new space node. All right, semicolon. Now at this point, on the next line, at this point, q is a pointer. We put a comment there saying now at this point, yeah, now q, q is now a pointer. Q is now a pointer to dynamically allocated memory in the computer that contains a node object. Contains a node object, yeah, and capital N for node, and then contains, and then THE instead of TEH. Okay, all right. So on the next line, you say Q arrow data equals 30, and then Q arrow next equals null. On the next line. Oh, you want to do it on the same line? That's fine. Up to you.
No, I thought you said no for some reason.
Okay.
Oh, you meant
arrow
equals
next.
now.
Arrow next equals null, right? Now let's try something funky here. Okay, on the next line. Let's link up. Our previous node, my node 2 to Q. Yeah. Okay. Now I put a blank line above that so that now we're trying something funky, right? So on the next line, now you can say my node 2 dot next, which was previously null. Remember, it was null before, wasn't it? Okay. Equals Q. All right. Now, because we dynamically allocated Q using new, we have to forget not to. We have to not forget releasing it back into the operating system before we die. So let's go all the way to the return, and just above the return, one line before, you can say delete Q, right? Because we have to remember delete Q, right? And then put a comment there. We have to remember to release memory back into the operating system, which we got with new. The OS, yeah, OS. You can just say OS. Yeah, that's fine. System is fine. We got it using new. We got it using the new operator. We got it using the new operator above. And you get a blank line after that too, because you can keep return and separate all the time. All right, now let's go back to line 61, right? One more blank line. Now what we're going to do is something really, really bold, okay? Now go back to the previous, you know, up to line 40 or something like that. Now where do you say, no, up here. Let's link up. Yeah, line 42 to 44. No, for 47 to 49. Copy it and take it all the way to the bottom. Yeah, 47 to 49. Actually, triple click and copy. You won't have to. Yeah, all right, that's fine. Paste it there. Yeah, one more blank line and then put it there. One more blank line, put it there. All right, now we'll print out my node. Let's print out Q. Let's print out Q through my node. Okay. Now this is, I'm going to leave it as an exercise to you because it's only a 5-minute exercise, 2-minute exercise, not Kai, okay? Because he's been, you know, kind enough to type, okay? Kai is still going to be typing, but one of you get rid of everything inside of the quotes and or what you got there, right? You guys fill it in, okay? And on the next line, left as an exercise to students, right? On the next line, put a comment there saying left as an exercise, live exercise to students. As a live exercise to students, fill in, yeah, students, right? And delete the red and the black, you know, everything other than the cout. Everything other than the cout, okay? And the end out, right? You got it. Yeah, get rid of that too, right? Fill it in. Can you guys do it? Or you guys do it? Are you guys able to do it? Now you got 3 levels of indirection. Yes? Yes or no?
Yes.
Okay, now if you can do this, then you are totally set up to do the for loop where you can have a linked necklace of 100,000 nodes, each one pointing to the next guy. And I'll show you next time, on Thursday, how you can actually traverse that node and find an element in there. You can do a linear search of the list. And I'll show you, got a long chain. I want to delete the 5th element from there. How do I delete just the 5th element? Leave the rest of it unchanged. Can you do that? You got to do all of that in question number 9 anyway, okay? But this is a way of doing that in the bare bones. The bare metal, they're saying, right? I have this complex linked list. I have remove at cursor. What does it mean? Go to this random location and do some minor stitching up there so that you can, you know, surgically remove one node and, you know, cover it up so that it will heal again. So if you can do this, I'll show you how to do all those other things. And when you can do all those other things, all of the other operations on complex graphs and trees, they're exactly the same, because what you're learning with the remove node and insert node is essentially what a surgeon knows when you go to medical school and learn, you know, this is how you do a suture, okay? A fine suture on a nerve tissue or, you know, or muscle tissue or something like that. And you got to practice that. You got to practice that in lots and lots of, you know, simulated environments, maybe, I don't know. But then the suture becomes, you know, second nature to you. And after that, when you are performing a complex, you know, heart surgery, right? Cardiac surgery, you're not thinking about individual sutures anymore. You say, okay, cut. Okay, you know, drain here. Okay, suture. And maybe you're not even doing the sutures yourself. You're saying, okay, you got all your assistants doing your sutures here, and you're taking care of a critical cut here. Right? So that way, when you know how to take this long chain, okay, of necklaces, and I can show you how you can cut anywhere, okay, and join up the 2 pieces, suture, right? Join up the 2 pieces, this side of the cut and that side of the cut, but yank out the undesirable bit from middle, right? And then take this end, tie them up together. Isn't that what a surgeon does? Yeah. All right. So I can show you how to do that with virtual structures in memory, where you have a long, you know, it doesn't even have to be a single dimensional list anymore, right? It can be a complex manifold of multiple dimensional, it can be a multiple dimensional structure in space, right? It's virtual space, okay? And I can show you how to do a suture right there. You want to go into that fabric, okay? You want to make a cut there for, you know, rectangular cut, take that out and then join it up. So that, someone comes there later, they won't be able to see that there's a cut. It's been healed. All because
Professor,
you know how to make these cuts. So
I have a
that's
class
all
at
we need to
11.
know. Yeah.
Is
Yeah,
it
you
okay
gotta
if
go?
I stop sharing? Yeah.
All right, I got to go too. I realized there's another meeting this afternoon. Thank you all for sticking around. What time is it, by the way? Kai, thank you so much. Okay, thank you so much
Yeah,
for
thank you.
typing. I hope I didn't stress you out by talking too fast. No, you were perfect.
No, it was completely fine.
Yeah, and building comfort and practice is very important. Okay, it's like swimming or surgery. You got to keep doing it until you get comfortable with it. Okay, no amount of reading or watching someone else do it is ever going to cut it. I can guarantee that right off the bat. Okay, you watch someone else code and you think you can code, it never comes. You got to code yourself, and because it's so easy, you should. Thank you all so much for your time. I'll see you guys on Thursday. Are you coming back on Thursday? Okay, try to come back sooner because today Keenan and I were just talking for a long time, and then Ashwat showed up, and then he was also hanging around board. Please come in sooner on Thursday, and we'll try and take this to the next level because suturing is the hardest. Okay, once you are comfortable with that, you can deal with graphs and trees, just like that. Thank you all. Kaylee, you can go, right? You're getting ready. Okay, thanks very much. Bye.
Bye,
Thanks,
Professor.
Professor.